Hello and welcome to the Embedded Frontier podcast, where we dive deep into the ever-evolving world of embedded systems. Whether you're an experienced engineer looking to stay ahead of the curve, a newcomer eager to learn, or a director looking to understand the latest trends, this podcast is your gateway to understanding the intricate world of embedded systems. I'm Jacob Beningo, your host, and the CEO and founder of Beningo Embedded Group, an embedded software consulting and education company that helps companies and developers modernize their development processes and skills so that they can develop affordable, reliable, and secure products in a timely manner that improves their customers' lives. Now, we do all this through our Embedded Software Academy, webinars, blogs, consulting, coaching, and other activities as well. In my 20 years designing and developing real-time embedded systems, I've had the privilege of working with clients across more than a dozen countries and successfully completing roughly 200 projects. Now, in each episode, we'll unravel the complexities of embedded systems, discuss the latest industry trends, and uncover practical insights that will empower you to excel in your embedded systems journey. So sit back, relax, and let's explore the embedded frontier together. In this episode, we'll be talking with Frank Herta, the CEO of Curtail Incorporated, about how open source software puts big companies at risk of zero-day attacks. We'll discuss DevSecOps and how one single security failure can lead to potentially thousands of attacks, along with much, much more. All right, without further ado, let's dive into Frank's valuable insights into emerging threats and how companies and developers can protect themselves.
Yeah, I've been doing security, as I said, for about 25 years and got started doing secure electronic transactions with a company called Verifone Internet Commerce. We worked with a small company at that time called VeriSign with about 8 people. So this was really early on. We were doing PKI transactions, securing credit cards, and having consumers buy from merchants, and then having all those transactions go back to the banks and verify those transactions securely. That was a big deal back then, right? We still do that today, right? And I was actually the product manager for a product called vWallet, where we actually stored credit card information in your computer, so you could, you didn't have to type in your credit card every time, right? And sometimes the more things change, the more they stay the same, because now we have wallets. Of course, they're on our mobile phones, but this is something that's been around for a long time. And then I moved to Exodus Communications, where I was sort of the director of their managed security software offerings. And so I saw a lot of companies doing. Exodus hosted a lot of different companies, up and coming companies at the time, like eBay and other companies like that, Yahoo. And so we saw companies that were growing and the security problems they were going to deal with at scale. And so we were providing firewall services and intrusion detection services. And at Exodus, we actually got hacked one time. And actually, we had gone public as a company, right? And so I remember the company had gotten hacked. The stock price fell. The executives were in meetings for multiple days, and we put out a honeypot out there that we concocted, and actually caught the hacker and traced him back through the internet hops. We had to go hop to hop to hop to the border gateway in Russia. And since it's being recorded, I'm not going to say anything more than that. But this notion of trapping a hacker and tracking them, we work with the FBI in some cases, right? That became the genesis. I left Exodus after we had gone public and everything, because that story told me that if one incident like this, and it turns out it was a kid sort of screwing around, if that could bring a multi-$100 million company at that time to its knees, that would tell you something. Exodus later went to multi-billions in value, and then actually dropped to nothing. They went out of business. But I left that company with a partner, and we started Recourse Technologies. And Recourse Technologies was about trapping and tracking hackers. This is in late 1999. And so we actually took the honeypot. We actually took the honeypot concept and commercialized that. We were the first company to commercialize honeypots. And so we would put them out there. We actually virtualized Unix, where a company down the road was actually doing that with Windows, right? That became VMware. So actually, as part of, creating multiple cages, what we would say is because somebody didn't want to buy one piece of hardware per honeypot, right? And so we actually did commercial honeypots, and this allowed you to find 0-day attacks, right? New attacks. We found code red. Also at Recourse, we developed a tracking capability and a non-signature-based intrusion detection capability based on what we called protocol anomaly detection. So we would model normal protocol behavior, and then we'd look for deviations from that. And that sort of allows you to find, it's not a signature-based thing, right? So we were able to find 0 days problems with that technology as well. And then we actually had a correlation engine that, sucked in other inputs from other intrusion detection systems, other firewalls, right? Things that people are still doing today, right? Actually was one of the industry's first SIMs, if you will. And so we had big customers like Sony, and we had a lot of military customers and banks and things like that. And eventually Symantec bought us actually in 2002, kind of at the bottom of the market, if you go back to that. But we were acquired, and actually our products are still in use today. And the reason I think that's useful background, because it led to my current thing that I'm doing now, where we're getting into DevOps, DevSecOps, because a lot of what I was seeing in security is still very reactive, right? And if you're just tracking and trying to run down attacks and you're running around with your hair on fire all day, that's not a good way to be, right? And 0-day attacks stem from a 0-day bug usually, right? Somebody has either intentionally put something there or they've made a mistake that is now exploited. And so we got to thinking, like, where are things going to go? And this is sort of the genesis of Curtail's, Curtail Incorporated, Curtail Software is what we're doing, is where at Recourse we were developing ways of looking at 0-day attacks. We're now working at 0-day bugs, i.e. bugs that aren't found, that you can't normally model for, right? Most of the way we look for bugs today is we have known tests. So we say, hey, I'm looking for that bug. I'm going to throw traffic and I'm going to test this, input X to find Y. Well, if you have input X and Y is not there, or Z or A prime, B prime are there, you're not going to find that. We allow you to find those kinds of issues. We do this in a way that it's a novel way, a patented way, where we actually compare two versions of software. So maybe you have version 1, you're migrating to version 2. We throw traffic at both versions, and we look at the changes from one version to the next. And it sounds like a simple concept, but imagine if you could actually use your production traffic. So your normal users, you can now crowdsource your user traffic and play that back at the new version that you're thinking about releasing. And now you can see what's changed, and did you introduce any regressions or things like that? So Cloudflare had a major bug a few years ago called Cloud Bleed. We could have found that before they released, right? And so this is kind of the genesis, and it allows you to find all kinds of interesting things. We don't characterize them with CVE numbers and things like that. You can correlate that because we're using a different detection mechanism. We're actually looking at the actual changes that occur. So it's not a statistical approach, right? We're not saying, well, based on things that we think have happened in the past, and correlating that to 70% chance that this might be a problem, right? Yep. I'm always interested in, hey, it's a 70% chance it might rain tomorrow. What does that mean? Yeah, probably bring your umbrella. But if you need to be exact, that's not in some ways, that's not good enough, right? And if you ask even security professionals what they do with something, hey, it's a 70% chance this is an attack, what do you do? Do you block it or let it go? You actually get a very strange smattering of answers on that, right? From security people. Yeah. Some people say, "Yeah, let it go." Like, really? I mean, 1 in 3 could be a really bad problem, right? Kind of 70%, right? But we tend to trust these numbers, right? And I think these are things we have to be careful of, especially with the rise of AI, where we're just, hey, AI is going to do it. Well, who's checking the AI, right? And if we just say, well, the computer said it's true, well, it must be, right? We have to be careful of that. So anyway, that's a little about my background. Hopefully that's helpful. And happy to talk about some open source issues, which I think we were planning to do today. So hopefully that's not too long.
Oh, no, not at all. No, that's perfect. No, it gives us, I think, a really good understanding of your background and kind of some of the stuff that you've been working on, and more importantly, even some of the challenges that people are facing, right, related to security and DevSecOps. Because as you mentioned, we want to talk a little bit about open source software, which today you can't get away from, right? As you mentioned earlier, the recording software is even using open source browsers and things like that. So
Yeah.
you can't get away from open source wherever you go, right?
Right.
It's for better or worse, I guess you could say, right? So with that kind of in mind, I know that as people are adopting more and more open source software, and you've mentioned a little bit about 0-day attacks already. So lots of people are starting to use. I mean, they have been using open source software. It's been prevalent for quite some time. Can you shed some light on why companies are at risk for 0-day attacks due to the use of open source software? Is it the companies themselves that are at risk, or is it their customers, or is it through the products that they produce? Could you shed some light on that?
Yeah, sure. It's a multi-stage question there, right?
Yep,
There's
absolutely.
it's actually it's both, right? It's the companies themselves, it's their customers, and that's because open source, has grown over the past 25 years, right? I mean, it's really proliferated. I think, I was reading that 80% of software, 70, 80, 90% of software that that your software publishers use today, it's open source based, right?
Yep.
My products are based, have a lot of basis in open source. A lot of the libraries those are all open source, right?
Yep.
And so it's everywhere, right? Like you said, we can't get away from it, right? And that has continued to happen, right? And everything is connected together, right? And everything is connected through open source in some ways,
Yep.
right? And so, I can't remember. It was a saying one time. Well, why do robbers go to the banks to rob them, right? Because that's where the money is, right? Well,
Yep.
why are they now hitting open source, right? Well, because it's so prevalent, and it's actually now could be potentially a weaker point, right? And so everybody believes that open source can be more secure than proprietary software, and in some ways it can be, right? It's out there for everybody to see, everybody to look at, everybody to test. You might get feedback back faster than everything like that. But we've seen some pretty clear-cut examples where that's been exploited, and that we've had trouble with things, right? Let's go back 10 years. I think one of the really kind of watershed events was Heartbleed,
Yep.
right? If you remember that, I remember, I think, hundreds of millions of us, I believe, had to change our passwords. We got a notice from our bank or something that said, please change your password, right? This was a flaw, a bug in the Open SSL TLS, the encryption module, right? That basically, if it were exploited, could allow certificates to be accessed, and basically allow you to read private information. Never a good thing, right? There wasn't a good. We obviously didn't find it. The cost of that, probably cleaning it up, has been hundreds of millions of dollars. I read 500 million some other day, as one of the other days. It's something. OpenSSL is something everybody used, right? It was the encryption mechanism that a lot of people used. That was a real problem. We've seen recently, several years ago, but after Heartbleed, we saw Apache Struts, right? Equifax, 137 million people, 140 million people, 1.4 billion. All of their identities had been, compromised, right there, right? So there's another one, right? Recently, Log4j, right? Last year. And so it's not that these things were believed to be insecure. Everybody trusted them. We got good use out of them. Log4j, the bug surfaced several years later, right? But there's also been some belief that that actually state-sponsored, some of these attacks could be state-sponsored, right? So you have to watch out. So you could, in the open source world, if you control the maintainer or the contributor or both, you might be able to sneak something in there, right? And state actors can do this, right? And so, yes, if somebody is actively watching that all the time, then yes, it can be policed better, but sometimes that doesn't always happen, right? And we've seen examples of this, as I just mentioned. The other thing now that's happening, just to kind of expand on your question, because it was very broad, right?
Yeah, it was. Yep.
We talked about partners, we talk about, is it our companies? Yes, there have been, as we've known, third-party attacks for many years, right? When we start connecting B2B, right? Everybody's, hey, I want, my air conditioning, guy has a internet connection with Target, right? They got breached that way, right? So we've seen these third-party, connections, which we have to conduct business, right? But a lot of times there are breakages in that thing, and now we extend that into open source, right? So recently you've seen third-party supply chain attacks, right? Which is a kind of a cushy little term, right? We've seen this on open source, right? So hackers are smart. They're, they don't mess around. And if they're state sponsored, they're looking for weaknesses actively, right? And so, they also figured out that, hey, it might be easier not to hack JP Morgan directly or Ford or, United Airlines, whatever. It might be easier to hack a repository that they all use, compromise that, and then when they suck down software from that repository, which everybody does when they're doing their application coding, now we're in, right? Yeah. And so and that's most of those open source, most of those are open source repositories, right? So there's an open source problem there, right? And so you're not, a lot of times you haven't built Fort Knox around these repositories, right? And so that is now a weakness, right? And so it's just like anything else, right? The weakest link, you gotta keep shoring it up, and it's the constant survival of security, measure, countermeasure. We talk about, what we're trying to go at Curtail is to find these problems earlier, right? Find them when they're code, find them when they're early on, shift left, if you will, right? I hate, I don't want to get too many buzzwords in here, but let's find them at the developer level. Let's not find them after we released or even later in the process when we, are testing, final testing. It's more expensive to find bugs later in your security software development lifecycle, right? And of course, it's the most expensive when your customers find them, and it's really expensive if you have a Heartbleed or a struts problem, right? Which, of course, that's an open source issue. But again, somebody coded that, not somebody, but groups of people in this case. And so finding these things earlier is a real benefit.
Absolutely. Yeah. The sooner you find stuff, the better. You certainly can't, just like with quality, you can't, at the end of your design cycle or development cycle, kind of attach, quality or security. It's something that has to be thought about from the very beginning. And as you've been saying, you actively work through that throughout the whole development cycle, and even after the thing's actually been deployed and is with the customer. So.
Right. And that's hopefully getting to DevOps, DevSecOps, right? Because, and look, I've managed software companies for many, many years, right? We have this habit of the developers develop, they code, they throw it over the wall to the QA guys, they look at it, they run tests, and then they go, yeah, I'm kind of done. And then you might throw it to the security people and they might run some tests. And we've got these silos, right? And those are weaknesses, right? And so DevOps, DevSecOps is saying, let's combine those activities. Let's look at this holistically and say, hey, if we're developing software, let's think about quality right in, right? Let's think about the security right away, right? Let's start implementing some tests early on, and also as we move down the life cycle, right? As we move down our pipeline or whatever you want to call it. And that's a really, important way to do things, right? Because if you're doing all these tests at the end, maybe you find some things, but usually there's pressure to get things out at the end, and you might miss things, right? And then, what else are you looking for? Are you only looking for known problems, right? So are you, there are all kinds of tests out there that are great that you should do, application security tests. There are network tests, DAS, dynamic application security tests. There are code tests, static application security tests. You actually do code, look at the code, source code analysis, all kinds of things. We actually at Curtail are proposing this thing called NCAST, that where you network comparison application security testing. So as I mentioned before, you compare the responses coming back from two like versions of software, and you look for the changes that have been introduced, willingly or not. Right? Obviously, you want to find the unwitting changes that have been introduced, and that's what we're doing. And so this also now gives you a much wider aperture, because you can look at, like I said before, you can look at your customer traffic. Customers do weird things to software that your testers never think of, right? Also, your own testing over time actually becomes kind of, it's non-usable anymore, right? Tests that you did, 4 or 5 versions ago don't work anymore, right? So being able to constantly have traffic that tests and exercises your software is really important. Your users do that very well, right? And so if you can use your users, you can use your existing tests. Now you have this very wide aperture to say, I've got all of these things in, it's better testing, right? It's to see what things have changed. And you can actually apply that to open source as well. And so we could talk more about that, but I'll expand on that in a minute.
Okay, perfect. Yeah, as you're kind of mentioning that, a couple of thoughts popped into mind, because you did mention how you were comparing the differences between two different versions of software to look for those differences. Now, is it just between different versions, or are you actually able to monitor that while a device is in the field and just notice if it's, network behavior changes over time, even without you having performed any updates? Is there multiple caveats there on how you catch changes, or, like if a device is actively hacked, in the field without a firmware update, for example?
Well, yeah. So we're looking at the network responses, and actually, it's a good point you make. We can find that, right? Because you can actually have a production version operating, and then you can have that working, and then you can have a version that's that you think is your release candidate. So now let's say everything is kosher, copacetic, and you push your release candidate forward. Now that's your that's the production version. You can still run that prior version underneath. And so if anything new happens with that production version in the field compared to the prior version, you might be able to pick up something that has happened early on, right? That you hadn't seen before. So you can do it before you release, but you didn't get enough traffic, right? But and also you can do it after.
Okay.
And so that's how you can see those things.
Okay, perfect. No, I appreciate that. I know, it kind of something I was kind of curious about, if some of the stuff that you're doing there. So, perfect. Yeah. No, I know you kind of talked about some of the comprehensive security measures that some of the companies can use, with open source software. When someone is working with open source software, are there, particular issues that you see as being kind of the main things that developers should look out for, that maybe lead to that could help prevent maybe some of the devastating security breaches that we've seen in the past, and prevent them in the future?
Yeah, I mean, you got to do the basic, blocking and tackling, right? We all use, as we've talked about, everybody's using open source software, right? So if your teams are on it, basic blocking and tackling, like I said, run your, design, make sure your software design and architecture includes security. Run the appropriate tests that you would run for your proprietary tests. You can run commercial tests against this stuff. You can run open source tests, scan it, run your typical application tests. They have things that are specific for open source. You would hope the open source community, they do the testing themselves as well, but you also want to test it with your application, right? And so, it's just good blocking and tackling, then document things. It's probably good to, if you have the time and resources, you're a big company, be a part of some of the if you're doing a lot of work with a certain open source library, to become part of that team, maybe, have one of your people be a contributor or part of the team, right? And so that's important. We'd like to think that at Curtail, we've got a way of helping with that too, because when we talk about looking version to version, going version 1 to version 2, we can actually look at open source versions because a lot of open source versions, are designed to do the same thing, right? So a web server, there are Apache web servers, there's Envoy web servers, there's Nginx web servers, right? They're all web servers, right? There are TLS versions that are comparable, right? There was OpenSSL that got compromised with Heartbleed. There is GNU TLS, right? These things that do the same thing. You can actually look at those in combination and say, hey, I've standardized maybe on Apache, but is that the right thing to do? Right? And so you can look at Apache versus Nginx versus Envoy and look at the combinations of other open source stacks below them and actually pass traffic through these versions and look at the comparisons of those. So we call this horizontal testing. So the application you may be testing with is the same. You're not looking, hey, I'm going from version 1, version 2 of my application. Now you're looking across different platforms and saying, is anything weird there? And by the way, you'll see a heartbleed because you'll pick up an extra heartbeat that was only present on the OpenSSL version, but it wasn't present on GNU TLS or NSS, the other TLS components that were, it's effectively did the same thing. They had a different attack surface. So you can actually start thinking of changing how you test, right? We tend to think of testing kind of in a monolithic, hey, I'm testing this, I'm looking for that, I'm only going to test this platform. But let's look at it in the context of other things. And open source actually allows you to do this. Actually, the cloud allows you to do this because you can mix and match these things in the cloud. Now, people say, hey, I'm standardizing and it's more efficient that way. It might be more efficient, but maybe after you've made, several version changes, maybe your stuff's not going to run as fast on Apache as it would on Nginx now, right? Or maybe it's not as secure. So we need to, again, we need to continue to evolve and think of things holistically.
Excellent. So, kind of thinking about, software testing from a holistic standpoint, and with open source software, how does that testing for open source software maybe differ from proprietary software that someone might go out and buy instead of using the open source versions? Do you see a difference between those, how you should test those if you're going to use them in your system?
Well, the question is who's doing the testing, right? So, if you're using open source software, right, generated by these teams out there that are a big community, right? OpenSSL, you've got all these different libraries, Apache, right? These are big teams that are doing it, right? And theoretically, lots of people contributing and testing that, right? So there is and should be testing done at the open source level itself. And so, they are, as they are coding something, they are hopefully running, the normal tests like I've described before, the, simple applications tests. They've got their, QA tests and things like that, right? Then you bring it into your, and you it becomes part of your software when you're, putting your application together, and right now it becomes part of your stack now, and the libraries that you use to make your software work, whatever you're doing, right? Your banking application or whatever. Now you have to test that, right? And you can throw general tests at that, right? Now, where the open source is combined with your, open source libraries combined with your proprietary software. So I think, early on, if it's just the raw open source, it's the raw project, that should have its own testing and being done there. And hopefully they are evolving. It's interesting that I think, within the last year, there's been a realization that maybe we're not doing enough testing at the open source level. I don't know if you've heard of the Alpha Omega project with Google and Microsoft, where they are saying, hey, we're going to put, millions of dollars up to test, Google and Microsoft are going to test open source versions, and then they're going to give their good housekeeping seal of approval on it, essentially, right? So the open source is supposedly testing itself. The teams are supposed to be doing that, but now Google and Microsoft are going to say, hey, we've done this testing to go beyond that, right? So now you've got industry stepping into the open source, which is kind of an interesting, change of pace there, right? But anyway, again, we bring that back into our, if we're software developers, we bring that in. We still have to test this as a system, right? We still have to test, the open source and our stuff as well. And so, I don't know if that really answers your question, but really the open source contributors are doing that, for the project themselves. now you have to look at that and test in context with how your software works with it. So you're probably doing a lot of the similar tests or testing, right? But as a software publisher, you've got an application that you're specific to. You're going to test the use cases for that. As an open source, you're testing the open source capabilities, right? So it's a little bit of a different thing, but a lot of the testing methodologies are, going to be the same. Hopefully the software development processes are somewhat different now, because open source is in the public domain, right? And everything, a lot of what is, a lot of the code is out there for you to look at, right? And so that's a difference.
Yeah, it actually allows someone to go and if they were worried about something, perform a code review versus proprietary, where you're usually using compiled libraries and you can test some of the peripherals, but not get your eyes on it to really do some white box testing. So
yeah.
Now, I know we've been talking about open source software and some testing, and I think that's a pretty good segue into talking a little bit about DevSecOps. I know DevSecOps has been really growing in the industry. I know within the general software industry, I think, has been taking off quite well. I know within the embedded software industry, it's trying to get going. There's a lot of interest in it. But for those that maybe aren't as familiar with DevSecOps, could you elaborate a little bit on some of the principles of DevSecOps and how it is being applied to open source software?
Yeah, I think I'll talk about in software in general. Like DevSecOps really is about it's somewhat of a culture change, right? And as I mentioned before, we have development, we have developers, a silo, we throw it over the wall to the QA guys, who throw over to the wall to the security guys, and maybe we look at it there, and then we throw it over to ops, and then we release it, and oh no, there's a problem, and then we scramble. DevSecOps is trying to make that process better, right? And it's not so much a technical change as it is a cultural change, right? So a lot of the technology is out there to test early, for example, right? To, to coordinate with our security teams and to, and our QA teams and to do things earlier. That's not something that's something we can do already, right? We just haven't been doing it, right? It does put more responsibility in some ways on the developers, the development teams, right? To say, hey, let's look at QA quality up front. Let's run these tests up front. Let's see things earlier, right? We believe very strongly in that, right? Because hey, if I code a new change as a developer, let me see how that ran against the last production version. We can see what's changed right away. And is that what we want, right? And then, let's bring security in that, right? Let's not wait until the very end. Are we surfacing security problems early on, right? And so we don't find them at the end, right? And let's bring the security guys in early on and say, hey, this is what we're coding. Does this make sense? And are we gonna expose ourselves to anything like this, right? Any potential security problems, right? And so it's really that kind of I don't want to say integration, that kind of teaming early on to really get and address these problems up front, right? And then have when we go through and do our releases, right? When we go, we've done our testing, we've got ops, the developers get that feedback back right away. Right. But we really want to get rid of these silos where we just say, hey, I'm in my box. I coded it. It was fine. The testers go, I tested it, passed my tests. The ops guys go, look, they said it was fine. I released it. And then, now you've got some big bug out there or your software crashed and everybody throws up their arms. So collectively, everybody has to take responsibility. Right. And if you do that early on and you involve the entire team, it's been shown that you can get better results. But like you've said, in the embedded systems, right, it's still evolving. People are talking about DevOps, they're talking about DevSecOps. In some cases, they're really doing it. But if you look at a lot of the products out there that say, hey, we're DevOps, we're DevSecOps, they're still very siloed things, right? It's still like, hey, you're the developer, you're doing this, right? And there is potentially an additional, some work from the developers that are going to, but it's eventually going to make their lives a lot easier, right? Because if you're able to code things that you can get those bugs out there earlier, you're not going to have this mad scramble where you're like, hey, we got a Sev1 bug out in the wild right now. We have to fix it right away. And now everybody's in a fire drill. It just can make your process. Nothing is a cure-all, but it can really make that process go better, right? And as I said, I've managed software for many years. That's where things kind of go crazy, right? I mean, it's all fun. It's all fine if we release our software, use it, customers love it. Hey, we love your product and everything. It's when there's a problem, right? And if it's a security problem, like, somebody just got access to my stuff and I think it's coming through your software, right? Okay, now you got a big issue. And so if you can avoid those problems early on, and it's shown that, a lot of these things you can find early on, right? Yeah. But if you're siloed, you find less of them.
Absolutely. And I think there's I'm going to interject kind of just one point for anyone who will be listening to this, and that at least who's a developer, is that doing these things kind of early, like you've said, and throughout, you catch things, you prevent problems from happening. For a lot of developers, doing security early, I hear a lot of developers gripe, right? Because it's extra headaches and things that they have to fight with throughout the whole development cycle instead of just knocking out code. But at the end of the day, you do end up with a more secure product. You work out the bugs, you find those issues early, get things in front of the customer, and that can help lead to a more secure solution down the line. And, like you said, the cost of, a breach of some sort or an issue with a customer can, it can sink a whole company, potentially, depending on what the issue is. So.
Yeah. And I think we just have to sort of think about is when you say just knock out code, now that security is part of that. Right. Yep. And really, I think it's a way for people to gain more experience. Right. I mean, if you have that security expertise, you can't do the way the internet is, networks and internet and code is proliferating. You can't write software without some sort of knowledge of security and involved. Right. It's just, there's, you used to be able to, you could put your software out there and, hey, maybe something would happen. You hang a server out there today. It is just bombarded from everywhere and all points on the earth, right? It is looked at, it is scanned. It is people trying to hack in there. They're trying to gain and it's a lot of it's automated. You got these things. Hey, I'm just right. And so, that's the world we live in, right?
Yeah.
And so, you can't just put you just can't put your head in the sand and go, I'm just coding, it doesn't work. Right. And we can't, as corporations, right. If you're worried about corporation, right, we can't just live like and say, well, it's, the QA guys are going to do their job. The developers are going to do their job. There's a better way to do it. And I think people will, are figuring that out, because hackers don't care. Right. They prey on that. Right. They're like, they're a little disjointed. We can, we know they maybe didn't do all the tests that they should have. We know we've already got this bug in there that they can exploit later. So, you got to be vigilant.
Yeah, absolutely. And, you kind of speaking to, how automated and how, how things are just, so prevalent. One of my favorite examples of that is one time I was working on a project and we had a little Linux box, and we literally, we had somewhere to go or something like that. And we said, oh, well, we'll just make it so that we can, get into this device remotely if we needed to, because we need to within, for 24 hours or something. And it took less than 24 hours for some automated thing in China to discover this Linux machine and hack it and install its own software on it.
Exactly.
It was, a lot of times people will think, oh, obfuscation, or, oh, there's so many nodes out there, my device will never be found or anything like that. No, it's, if you expose something out there in the wrong way, it will be found extremely fast. And exploited.
And you just described one of my initial loves in security was honeypots, right? That's essentially the honeypot idea, right? There with the honeypot, you actually want that to happen. You want to see, hey, how did they exploit this? Because you want to see it in a honeypot before you actually see it in your servers, right? In your own stuff, right? So that's the whole idea with honeypots. Let them fire away, and they use this attack. Oh, they use this automated thing. Are we prepared against that, right? and so, but yes, that happens all the time, right? It's not just like, oh, is there some wily hacker out there that's like saying, I'm going to try and search right now? They've got these broad scans that are happening out there all the time, everywhere, and so you just can't say, well, maybe they won't find my code anymore, right?
Yeah, it's guaranteed they will.
Right.
So even though in our heads the statistics seem, oh well, no, the odds of it, no, the odds are actually very much in the favor of them finding it. So
right, and I've actually seen some cases where, it used to be uncool to actively hack somebody's without telling them, right? I see people doing that all the time now. I was on the board of and somebody just decided to. They said, "Oh, I know somebody will hack." I said, "Well, our people did they know that you were going to do that?" No, we just did it. And so that whole mindset, I said, "Okay, so you just port scanned us for what? Why? Why did you do that for?" And without telling us that we're doing that. Oh, and then we got, oh, okay, great. That's really helpful. So and these tools are so readily available. People don't, the etiquette isn't there anymore, right? And that's probably going away too, right? So a lot of times the rules that we used to play by are gone.
yeah. Oh, absolutely. Absolutely. Yeah, I remember, again, as an example, I remember in college when, we'd be playing around and we'd get into someone's machine and then we'd leave a little note saying, hey, here's some steps you need to follow to secure your system. But anyways, you kind of mentioned
that, right? A lot of people just said, hey, they wouldn't leave a note. They're just, you left you could leave a back door so you get in later, right? I mean,
exactly. It was one of those things where like, oh, can we see anyone's computers and get in one? That's like, oh yeah, we can. Okay, well, what do we do? Here, tell this person, hey, you realize you're exposing all this stuff online, dude. Right. Whatever. But those were many years ago. I don't play with that kind of stuff so much anymore.
Good.
But anyway, I digress a little bit. So, kind of talking about some of these threats, and over the course of time here and how these threats have changed, and maybe even thinking about the advent of AI and all the AI tools that are starting to come out. How are the nature of threats starting to change? And with the use of open source software, how is that? How are those threats changing for open source?
Yeah, sure. I think we talked a little bit about earlier, like third-party supply chain. Right? I mean, again, we're attacking the repositories now, right? That's now a weakness, right? We used to think of third-party attacks was, like I said, Target, their air conditioning. I think their air conditioning supplier, that was a fault that a hacker got in, right? They had attacked the air conditioning supplier as a third party, and then they were able to get in through Target. I believe that was there was some big store chain. Well, now that weakness from a third party is the actual software that we use from an open source perspective, right? So an NPM, right? We've got these things. And so again, we attack that. And so that's kind of been the new thing du jour, right? Again, it's as we continue to pump out more code, especially more open source code, we need to do a better job of securing that. Now, as it also we take it from third parties, it's not just the code itself, it's how the code is downloaded, right? And so we have to make sure that that's all that pathway is secured as well. So, as I said earlier, threats are going to continue to evolve. I don't have a crystal ball on what's next. But I believe that if we, look at things with different techniques, like perhaps like what we do, I think you start finding things and understanding how software is going to work, and it's going to work under different conditions. And that might alert you early on to things that you might not have thought of when you coded it, right? And we just can't passively, sit back and say, well, somebody's looking at it. Right. I mean, it's out there. It's, it's published. It's good. Right. I mean, think about, and we know this, that the, as I said before, the, state actors are looking, and we always think, open source, hey, it's the good guys are doing it. Right. And there's, but if you can insert or you pay people to actually code things that leave backdoors in there, maybe somebody's going to miss it. Right. And, if you've got the world contributing on these things, right, how do you vet those things? Right. And in a private industry, you can do that a little bit better in some cases. right? Obviously, people can come in and, you've got insiders and insider attacks. But with open source, that really is it is compromisable, right? And so you have to watch out for that. And then the other thing is, and I think this is the one thing that we always really have to watch out for, is complacency, right? And so, I just think that it's a problem. I think everything's going to be okay. I think this is a problem with all the AI stuff, that's coming up. It's like, is it doing what we want it to do? Are we in charge of it? And do we just assume that if the AI says it's true, right? I mean, we said 99%, 95% of the time ChatGPT gives us something, but then it gives us these hallucinations, right? Well, what's real? What's not, right? And so complacency. And then also, we know we have incidents, right? We have responses. We have problems. We need to respond. And part of security is how quickly you can respond to that, right? I mean, it's time-based security, right? Is how much time is there, for the hacker to get in, and then how much is it once he's in? Can you narrow that window of how long they have before you get him and root him out and find it? But a lot of times, that becomes a problem. And then if have you been compromised? We've seen from some of these other open source attacks that Log4j, right? There was one guy, who was responsible for maintaining it. He had a full-time job, right? I think he was working out on the East Coast, right? So who's maintaining this? I mean, we have billions of dollars in intellectual property and, assets, whatever, tied up in this software, and you've got somebody part-time. Heartbleed was the same thing. When the OpenSSL thing, they was like, we need to fix this. We need to get a patch out right away. And it was one part-time guy that was maintaining the OpenSSL project. Right now, I did a little research, and people the project saying, "Oh, we're well staffed," but a lot of times they're not. They're not compensated, right?
Yeah.
And so that's also a problem, right? And so we just think, oh, well, if I have a bug, it'll be fixed. I've got this mission critical stuff running, and I need well, what's the average time it takes for a bug to get fixed in an open source, project? It can be 60 days, I think, sometimes, right? You can't wait 60 days. Yeah. If we're in a warm or hot war with China that is including cyber problems, you're not going to wait 60 days for a patch on an open source component if we're using open source, which we do. It's just not going to work, right? And so, we need to make sure that those capabilities are there as well. I mean, you can complain about, hey, the proprietary software guys don't, fix their software sometimes as well too, and they don't. But you got a phone number to call somebody, right?
Yep, exactly.
For it, right? And so you can do that, right? And so can't be complacent, and you also have to make sure that we have the response capabilities to get there and fix these things quickly, right? And a lot of times that, I think, is where we're lacking. So, if you're asking me where things are going, we need to shore that up going forward.
Okay. Yep, absolutely. Yeah, it's quite amazing that, when people look at those projects, you might think that there's a lot of money and people backing them, and it's literally someone who, for a hobby, is maintaining that open source project.
Right.
And they've got a full-time job and kids and a few hours. Yeah.
Yeah, that bank is running on that, and oh boy, now you have this problem.
Oh, exactly. So, what advice would you give to a developer or a manager who's just starting to use open source software in their projects? Can you give a couple of thoughts?
Yeah, I think obviously let's start from the big beginning. What's your security policy? Have you done your audits? Have you done your testing? What are your goals? Kind of that thing. Have you and talk to some security professionals and things like that. But if you're specific to open source, look at the OWASP site, right? Follow the OWASP top 10. Are you doing your good housekeeping seal of approval things, right? If you're using specific open source libraries, get on their message boards, get on their alerts, right? Follow these things. There's a lot of, commercial and or open source alert services. Get on some of those, right? That are specific to the things that you're doing. Get involved, right? If you have the resources. Now, small companies, sometimes they don't have the resources to do that, but a lot of these things are free, right? And so, like, if you got an OpenSSL project or you're using OpenSSL, you can get in on that project, and they have a website, they have resources, use them, right? And then actively test, right? Actively test with commercial software, your own tests, and things that are published. You use the open source tests that are out there as well.
Perfect. Thank you very much. And then I think what we'll do here real quick is, I have kind of one last question here for you, kind of related to maybe you just sharing a little bit about some of the exciting developments in future plans at Curtail related to open source security and some of the stuff that you guys are working on to help the community.
Yeah, and I thank you, Jacob, for giving this opportunity. Really, I kind of mentioned earlier being able to look at different open source packages in comparison to each other. Nobody does that, right? And so again, we can look at software going from one version to the next as your application. Hey, I just made these changes to my application. But let's look at the open source. So you can actually look at open source versions and see how they've changed, right? You go Apache 1.0 to 1.1, right? Whatever the version they're on, it's certainly not one. But let's look at Apache compared to Envoy. Let's look at compared to Nginx. How do those differ, right? Do they do this? A web server should serve web traffic. Is it doing it in the same way? Are there any header changes? Is there any extra data that's appended to these websites? We can pick those kinds of things up. Those are things that hackers exploit, right? And in some ways, if they're all doing the same things, you can go, you know what, that looks good. Unless they all different coding groups have all done the same thing wrong, right? That looks good, right? And this kind of goes back to how they design things for the space shuttle, right? You actually would have they would give 3 engineering teams and say, here's the spec, make it do this, and they would on their own come up with it, and they would do, and you want it to do the same thing, right? Yep. It's very similar, right? If you know that it's doing this thing, and so we could have picked up like a heartbleed problem potentially, right? Because the OpenSSL had this extra heartbeat that happened when certain traffic hit it, as opposed to an Nginx, which didn't have that, or I'm sorry, as opposed to a GNU TLS or a NSS TLS thing. So thinking in terms of what we call like that horizontal testing, nobody's doing that, right? But how do you verify where one open source package is doing? I mean, you just sort of say, yeah, we use Apache. That's all we use. We use Apache. We've always used Apache, right? Yeah. Maybe that's not the best thing, right? Maybe you could be, like I said earlier, performance changes and also security issues, right? You just understand your software better in context with looking at different things.
Absolutely.
And that's what we do at Curtail, right? We have a unique way of looking at that and looking at how traffic, your own production traffic, any kind of test traffic, what are the changes that it introduces going from version to version vertically and version, across versions horizontally? Again, maybe Apache, Envoy, Nginx. What do those mean?
Perfect. Well, thank you very much. We really appreciate you taking the time to share your expertise with us and your insights. And do you have anywhere where people could, like a Twitter account or any social media stuff like that people can learn a little bit more, or website, maybe the Curtail website?
www.curtail.com is the best place to reach us. And please, engage with us, and we'd love to talk to you.
All right. Perfect. Thank you very much. Really appreciate it.